All right, in order to add and subtract matrices, the matrices need the same dimensions. If they don't have the same dimensions, it is not possible. Another thing we're going to go over is a scalar and scalar multiplication. Scalar is just going to be a value used to multiply. Okay, and then our next one, we have scalar multiplication. With scalar multiplication and matrices, we are going to take a value and multiply it by all of the entries in the matrix. So a value multiplied Okay, so a value multiplied by all the entries in a matrix. We're going to go over what that looks like with example 3. We are going to perform the indicated operations if possible. So remember, if they don't have the same dimensions, we cannot add or subtract them together. So for letter A, we're going to add matrix B plus matrix A. So we're going to copy those down to -7 on top, 6, -1 on the bottom, plus A, which is 8, 3 on top, 4, 0 on the bottom. Now, the reason the dimensions have to be the same on this is because we're going to take the entries that are in the same row and column number from each matrix, and we are going to add those together. And our answer is also going to be a 2 by 2 matrix because these are both 2 by 2s. So for this first one, we're going to take 2 plus 8, and that will give us 10 for the entry on the top left, row 1, column 1. Then we're going to move on to row 1, column 2, and in this one, we're going to take -7 plus 3, and that will give us -4. And that goes in the same location as where those two values were that we added together. Next, we're going to do row 2, column 1, 6 plus 4. That gives us 10. And it goes in the same location. And lastly, -1 plus 0, and that will give us -1. This new matrix is the one that would be your final answer. Okay, then we're going to go across to part C. This one, we have matrix A minus matrix B. Starting with A, we have 8, 3, 4, 0. And then for B, we have 2, -7, 6, -1. With subtracting, you just want to be careful with the negatives and the double negatives. Those get a lot of people. So this one, again, starting in row 1, column 1, we have 8 minus 2. That'll give us an answer of 6. Then we have 3 minus -7. So if it's helpful, you might want to write it out so you don't forget this double negative will actually change it to a plus. That will give us 10 for that new entry. Now we have 4 minus 6. That will be a -2. And lastly, 0 minus -1. And again, if it's helpful, you can write it off to the side so that you're not accidentally messing up with those double negatives. And that would be our final answer. 6, 10 on top, -2, 1 on the bottom. All right. Those were adding and subtracting where the dimensions have to be the same in order to do the operation. Next, we're going to do scalar multiplication. So scalar multiplication is very similar to distributing. So we're going to put this -2 in front of the matrix B, which was 2, -7, 6, -1. Yeah. And just like distributing, we are going to take this value out front, our scalar, and multiply it by all of the entries inside of our matrix. And then the result, or the products, will be our new answer. So this one would end up equaling a -4, +14, -12, and a +2. Make sure you're being careful with if your answer is positive or negative when you are multiplying with a negative answer. Okay. Next, down here, example B, we're going to add matrix A plus matrix C. So this one we have an 8, 3, 4, 0, plus 1, 5. Now, if you look at the dimensions, this first one is a 2 by 2, and the second one is a 2 by 1. Those dimensions are not the same. So that means we cannot add these two together because there's no entry for us to add this 3 to and our 0 to. So that's going to make it not possible. So with a problem like this, you're just going to write not possible next to it. No other work is required other than saying not possible. Okay, I will come back and do D and F at the end. So if you need more practice, stay for the whole video. Otherwise, at the end of the video, you can stop and come back to this. Okay. Example 4, this one is going to be using equal matrices. So remember, when they're equal, that means they have to have the same dimensions. They also have to have equal entries. So the ones that are in row 1, column 1, those two entries have to be equal. In row 1, column 2, these two entries have to be equal. Same thing, row 2, column 1, those have to be equal, which we can clearly see, both -10. And then lastly, row 2, column 2 also have to be equal, and both of them are -9, so we are good there. Now that we know that they're equal and which entries have to be the same, we're able to set up equations to solve for x and y. So in this one, the -2x has to be equal to 6. That gives us an equation to be able to figure out what x has to be. Divide both sides by -2, and we get x is equal to -3. We can do the same thing for our y variable. The -8 and the y, those both have to be the same because the matrices are equal, meaning y is -8. Okay, so some of them are going to be very straightforward, like that problem. Other ones are going to have a few more parts to it. With problems like this, if there is a scalar in front of either of the matrices, I would recommend getting rid of that first. So do your scalar multiplication before we try to figure out what's equal to each other. So we're going to go ahead and multiply this 2 by all of these parts. That'll give us our new matrix of 2y minus 1, -6, and 0. The other two are going to stay the exact same. So 5, 4, x 8 equals -5, 3, -7, 8. Okay, so we know the two on the left side, when they are added together, are going to equal the matrix on the right. We are still going to be identifying the parts that are in the same location of our matrix. So row 1, column 1, we have a 2y, a 5, and a -5. When we set these up, we are going to follow the same order that they show up. So we're going to start with the 2y, and then we're going to put a plus. So 2y plus. Then we're going to go to our next one, 5 equals, and then the entry that it has, -5. So it's very similar to before, except now we're adding the matrices without showing the work that we're actually adding them together. If you would like to rewrite it where you add all of these values together and then set up your equations, you can. But I feel like that work is an extra step that's just not necessary. When you're solving, again, also be careful with those negatives. I see a lot of errors on a problem like this one. So this way we get 2y equals -10. A lot of people will accidentally put 0 there. And when we divide by 2, we will get -5. So that is our equation for y. Now if we look, x is in row 2, column 1. So we're going to look at all of the entries in row 2, column 1 of all of our matrices. Then we're able to set up an equation. So we'll start on the left side, -6, put our plus sign, x, our equal sign, and then -7. Now we have an equation that we can solve for x. We want to get rid of this 6, so we can add 6 on both sides, and that will give us x equals -1. All right. If you are good on operations with matrices, you can jump to the next video. If you would like the last two examples, I'm going to go over D and F now. All right, so for example D, we're going to take matrix B minus matrix A. So for B, we have 2, -7, 6, -1, minus matrix A, 8, 3, 4, 0. Okay, when we're subtracting, again, we're going to subtract the entries from the same location. So we'll have 2 minus 8 will give us -6. -7 minus 3 will be -10. Next, we can do 6 minus 4, give us 2. And lastly, -1 minus 0, which is just going to stay -1. And that would be our answer for matrix D. Next, example F, they want us to find 4A. So we're going to take 4 and multiply it by all of the entries in A. With this one, it's, again, very similar to distributing. So we're going to multiply this 4 by every single entry in there. You want to be careful that you don't forget any. For this one, 4 times 8 is going to give us 32. 4 times 3 would be 12. 4 times 4 is 16. And 4 times 0 is 0. When you write your answers, don't forget to put the matrix brackets around them. All right, so that's everything on this page. The next video is going to go over the system of equations working with currents and air speeds.